Joining me today, Elissa is Vice President of Engineering at Google. She runs the software engineering organization for Google Nest. And I think it's going to help us give us some real insight from a hyperscaler perspective on some of the trends that we're talking about today around the cloud. And I think Sanjay left us with some good nuggets when he's talking about the amount of data alone that sort of Micron captures. Jaime Montemayor is the Chief Digital and Technology Officer of GM, leading a monumental digitalization efforts at GM, all the way from IT, digital, data and analytics, cybersecurity, et cetera. So giving us more of an infrastructure perspective from a company. And then Mike's the founder and CEO of Datometry, which is, conveniently enough, a Celesta company. Awesome. It was a company that's redefining how the world uses and manages databases, and I think we can get a little bit more into that in a second. Today's discussion is really meant to focus a lot around hyperscale cloud computing in terms of the market and technology and financial trends, and we're just going to jump right in. Just for a bit of context, global IT spending is projected to climb about 5% to almost a little over $4.5 trillion in 2023, driven in large part by an 11% increase in cloud applications to almost $1 trillion. Jaime, maybe you can start us off by giving us a perspective on what are the key drivers of this cloud growth, please?
Well, obviously, it's digital transformation. Digital transformation across all industries is driving that surge. If you look at it from a company perspective, what we're looking for is time to market and scalability. And so those two elements, clearly define, how fast you need to move into the marketplace. And the previous model of on-prem capability coupled with capital-intensive solutions just doesn't fit the bill. So the cloud gives you that opportunity to accelerate your move into the market and scale once you are there.
And maybe you can give us some comments on why isn't it growing faster? And it seems like 11%, but there's so much going into cloud, so much data.
Yeah, if you think outside of the current macroeconomic conditions that are hindering everybody, there's really four key reasons. The first is the regulatory, privacy, and security considerations, right? The laws are changing so rapidly, both at a state level and then at an international level, that people really have to think through where they're going to put their data and how to think about where the various regulations that are in place in the locales that they're putting their data. The second is the migration of tech skills and even just the technology, right? Like I think back to, if you remember, migrating from a 2-tier application to a 3-tier application. That was a big deal. You had to retrain all of the developers to understand how to re-architect those applications. And then you had to actually modernize the application. We're in a very similar world right now, where it's basically taking what was a 3-tier application and making it a distributed system. And that's very different from a mental model perspective. The third is cost. When the cloud first took off, it was a developer at their desk with a credit card, spending at will, and that clearly doesn't scale super well. So now as new disciplines and organizations like FinOps are coming into perspective, that's driving how enterprises think about how they're going to spend money on the cloud, how they're going to optimize it, and how they're going to control it. And then finally, it's change, right? Like organizations are made up of people. People don't really like changing all that much. And so an organization to change really has to go through change management, and that takes time. And so those four things, I think, are what really are holding back kind of the industry from moving forward, but it's just a matter of time.
And maybe staying at a high level, and over to you, Mike. If you think about, actually, one of you said in our prep session, cloud outside Silicon Valley looks very different. How has it changed, or how has adoption varied by industry, whether it's software, financial services, healthcare, et cetera?
Yeah, we are probably in a particular vantage point that is unique because we work with our customers across multiple clouds and across all industry verticals. And the future is here, but it's not distributed evenly, I think is the big quote. And what we see is really a very uneven uptake for interesting reasons. And one particular one is really FinServ, where it's a bit of a paradox. FinServ is usually your early adopter for any technology out there. But when it comes to the cloud, FinServ had a bit of a hard time kind of wrapping their head around. And you might recall Jamie Dimon last year, I think in an earnings call, said, if I could move to public cloud tomorrow, I would spend $2 billion today. And it seemed like an outlandish amount, but if you look closely as to how much migration really costs, it might actually not even cut it. But it was very interesting to see how they finally kind of got that urgency to move to the cloud and move fast. And I think it's really in the innovator's dilemma here that plays out. FinServ had really sophisticated, very involved IT infrastructure for a long time. And it just takes a while to unwind from that and kind of really, when you have so much market and thought leadership to kind of go to a new paradigm, that's just really a challenge. And I'd like to think they're now at that point, all of FinServ, to have really embraced that or at the beginning of that. And over the next couple of years, I think we see a huge rush in this regard. In the meantime, organizations that you typically do not associate with early adoption, like, for example, retailer or manufacturers, they didn't have that barrier to entry. And so for them, it was much easier to kind of get into the cloud very early on. But I'd like to think that 2023 is the year where we see this kind of really rush to the cloud. I will admit I said that last year too.
And Elissa, so we just talked a bit about how the industries may migrate. Maybe you can talk a bit about how the products have migrated from a cloud perspective as well.
Yeah, if you think about the early days of personal computers, when you were programming, you actually had to know how to use pointers to memory. It was very complicated. You needed to know the low-level internals of the computer. And then over time, it moved up the stack, as we like to say, with the introduction of the Java virtual machine and .NET, it abstracted a lot of that away for developers. And the same thing's happening in the cloud at a very high level. You had infrastructure as a service, then platform as a service, and now as you move up the stack, you have serverless. And that really helps to abstract away all of the complication of the infrastructure as a service so that developers can build applications very quickly without having to know exactly what's underlying all of the infrastructure, even the platform. And that's a really big enabler for the market.
And Elissa, you actually laid out some really interesting things around tech skills and cost and regulatory, et cetera. Jaime, maybe well, before I go to you, did you want to comment at all on anything that Elissa said or talk about cloud native applications?
No, I mean, I think I was going to make a comment that it's just how, from a retailer perspective or from a manufacturer perspective, we're now automating things that we never automated before. So there is a natural growth, and for instance, in our case, we're investing a lot in automating consumer experiences. So it's a new space for traditional companies that are driving the surge in demand for cloud computing. And as Elissa was mentioning, in the beginning, it was just about infrastructure as a service, but as we get into the business of automating consumer or client interactions, we are quickly finding that we need higher level of computing integration. So platform as a service becomes the next frontier for us. And down the road, we see, serverless computing. We just heard from one of the previous speakers, how in the future is about data and sophisticated compute that have to come together. And so for us, that's the next frontier as we continue automating more and more of our supply chain.
New products, new industries, AI, automation. Maybe, Mike, you can comment a bit on and this is Elissa's point from earlier, but maybe start us off a bit on how do skill sets need to change in order to address all of these from a cloud perspective for the large?
Yeah, when we start a project with a new customer, we tell them upfront, your success will depend on two things, people and processes. We got the technical stuff, we got that covered, but people and processes will kind of determine whether this is going to be a 6-month project or this is going to be an 18-month project or even much longer than that. And in our business, we move major workloads that are today on kind of legacy data warehouses onto systems like BigQuery without you having to change your application. And so we have developed really kind of a good sense for how big a project is and how complicated this is and all. And yet, the project durations vary vastly. And it really comes down to, as Elissa said earlier, well, nobody really likes change. And when it comes to the inner sanctum of IT, not permitting change is part of the job description almost. And so we're asking that group to really change now. And that makes for a couple of really counterproductive effects, I would say, because a lot of people have built careers and resumes on a particular technology, and they master this technology, they're fantastic at that. And so suddenly they feel the value of that is being taken away or at least diminished in some way. And I think the critical thing here really is for enterprises to understand how to ease their folks into this, how to make clear that their skill set is being valued and transformed, and really kind of figuring out what would that transformation look like so that everybody kind of understands what their path in the cloud looks like and how it is not kind of obsolete now.
Just building on that, you know, I kind of see the skills evolving in two aspects. I mean, skills to move into the cloud and skills to grow in the cloud. So as you think of skills to move into the cloud, you know, Mike just mentioned, you know, how important it is change management, you know, being able to have the right tech support to enable that transition in the most cost-effective way. But there are some other skills that are not as obvious, like architecting solutions. You know, for the most part, companies that are rushing to the cloud are primarily using the cloud as infrastructure as a service. But quickly you realize that to scale in the cloud, you need to re-architect your solution. So architecture skills become really important. As you're in the cloud and you want to grow, ways of working become more important because you want to scale the use of those capabilities that you're building, especially if you're doing data and analytics intensive solutioning, and or you are building customer or client facing capabilities. You need to be able to scale those capabilities so ways of working become the next frontier in terms of skills development.
And maybe switching gears at least to one of your other points from earlier, talk a bit about some of the regulatory and security and other things that companies need to think about, both hyperscalers and companies and those who are making specific products when moving critical functions to the cloud.
So, you know, if you think about one of the big issues with or hindrances to moving to the cloud, it's really all about data management and planning for it, right? And that's because of those regulatory, privacy, and security considerations. But one of the big benefits of the cloud is that you can harness all this computational power to do analytics and generate insights based on the data that you have. But that problem with data management is now not only regulatory-wise, you know, you have to put certain data in certain states or locales, but then you also have to think through how you're going to partition that data from your on-prem, the edge, to the cloud. That's a pretty hard combinatorial problem to start. Then you have to overlay the fact that different types of problems are solved by different types of computational resources in terms of how quickly they can be solved. So you might have data located somewhere and you need to move that data to be closer to a TPU, for instance, if you're doing machine learning types of problem solving. And so that becomes a really difficult problem for companies to think through. You know, I'm planning my data migration or my data management. How am I going to do that over a period of time so that I can generate the insights that I need or automations that I need as quickly as possible to have a competitive edge in the industry? And that type of thinking and the way that it's adapting on literally a month-by-month basis with the regulations that are changing is a huge consideration for companies.
And Jaime, from your perspective, how do you think about some of these different architectures, the benefits and risks of different architectures, everything from proprietary to hybrid to sovereign, et cetera?
Yeah, well, as you mentioned, as we begin the race of moving our data to the cloud, you know, issues like data privacy, data governance, data management become now a lot more relevant because you're no longer in control. And, you know, you hear terms in the industry like hybrid cloud or sovereign clouds. I mean, hybrid cloud is inevitable. All companies that have some type of legacy infrastructure that move into the cloud inevitably in the early stages will end up in a hybrid environment. You'll have to have some compute on-prem. You'll have to have some compute on the cloud. And that brings up challenges. Again, you can't have two standards for managing, governing your data or protecting your data. You have to ensure that you have the same across the board. The other trend in the industry are sovereign clouds. You know, as we know, there are some geopolitical pressures to keep some data within certain geographical boundaries. and/or companies are sharing data, but they want to protect their data. They want to make sure that this data is shared for a specific purpose, but we're always able to protect it, from a privacy perspective. And so sovereign clouds are definitely an area of evolution. Companies that in multiple industries that are putting consumer data and/or company-sensitive data in the cloud will wanna work with providers that have the ability to enable that data exchange in a protected and secure manner.
And Mike, how do you, in starting a company, how do you think about the various delivery methods in going to market, whether it be hybrid, sovereign, totally on-prem or totally in the cloud, et cetera? How do you approach that from a startup perspective in addressing an industry that's sort of moving so fast and different demands across different sectors and architectures?
Yeah, I think it comes a little back down to where you started out at the beginning, that the cloud isn't the same for everybody. And as a software startup here from the Valley, we were born in the cloud, if you will. And so it was a natural and the logical thing to do. But for everybody else, there's a huge lift that needs to happen. And as Jaime just explained, you end up with hybrid, not because you want to, but because you have to. And there's this very significant transition. And there are a couple of proponents who think that hybrid is going to be a forever game. I think for things like IoT, where you have sensors, where you have hardware that you really have to have outside the cloud, sure. But everything else, I think, would like to think, is moving to the cloud sooner or later, and it's gravitating there. But then the next question here is, and Jaime also mentioned this, like, well, there's the moving to the cloud, and then there's the moving in the cloud, if you will. It's really two things to think about. And I sense that a lot of enterprises are still somewhat reluctant to say, hey, we make this big investment to move to the cloud, and are we really making the right choice here? And what I see our customers certainly have really top of their mind is multi-cloud. And not multi-cloud because they want to do cloud hopping, so to speak, but really because their existing environment has been, let's say, fragmented by M&A activity and all sorts of things. Nobody really wanted that environment, but over time it has kind of developed in that. And so they're looking really for, in the next generation, hopefully this doesn't have to be the case. What really multi-cloud means for them is the ability to move more kind of as an insurance policy rather than a cost trade-off or so. And I think this is something that is probably the next frontier here in cloud, where today we're way too much focused on how do we make this work right now versus how can we build an environment in which enterprises then can really freely move. I think I didn't answer your question, though, but...
Still very interesting. Anyway, I think it was great, though. But maybe thinking about multi-cloud, all these various architectures, we're talking about software and software native. We just had a silicon panel up here maybe just a little bit ago. I'd be really curious to, without talking about anything internal, but if you're moving around, you have tons of sensors, you have lots of different new applications coming, you have many, many different processing requirements, as you talked about as well. How do you think about where you need to own your own architecture in the case of TPUs versus outsource? Or how do you think about how much hardware design you physically need to have in-house? And whether or not, Mike, for you, we'll sort of go maybe down the line, start with Elissa first, but go down to you lastly, and Mike can talk about whether it's an off-the-shelf or how do you think about the hardware requirements underneath for the cloud vendors that are serving your product to be able to better optimize your product. Again, nothing confidential to Google, please. I know you wouldn't do that anyway, but just give us a sense for one of the few companies that has world-class hardware and software in the cloud, how, if you can, how you make trade-offs from a software design and cloud and architecture perspective.
Well, I think right now, and this is to Mike's point, everybody's moving to the cloud, so it's a very early, kind of the nascent stages of cloud. Folks are really trying to look at what's the best way for us to get the insights out of our data and what cloud gives us that advantage. And that's where things like TPUs are well suited. If you want to do machine learning, then you're going to choose a cloud that actually has that type of computational power at scale. And that's cost effective as well. Now, moving forward in terms of, what does the architecture look like over time, it goes back to that point I made earlier, which is how do you partition your data across on-prem, edge, and the cloud? And in partitioning that data, how do you make sure that the computation that you want to do based on the data that you want to compute upon is actually close to the compute, right? So how do I make sure my data is close to my compute based on any of the requirements of that specific data? Because you have to have the right data at the right place for the right computational workload. And then you generate, hopefully, the right result. And so we're such in the early stages, but if you think of what's kind of emerging, you see folks making sure to have compute close to the data that they need, and these new workloads, and even networking, right? Like I think back to the early days of HPC, high-performance computing, and you had different workloads across different high-performance computing clusters with different interconnects, all based on the type of problems that you want to solve. Now you can think of that same problem being exploded across on-prem, edge, and cloud, and across clouds even. So it'll be pretty interesting to see how the architectures emerge. I think it's a little early, though, to say with any definition.
And how do you approach that problem, Jaime, and we'll talk in a second after this, just to give you a preview of all thinking about the cost side too, right?
Yeah.
Talking about doing all these things, but we'll stay away from cost for a second, but how do you think about managing all the various?
Yeah, so the obvious answer is we start with business outcomes first. So business outcomes need to govern the tech decision. So we don't, and so once you are past that and you are clear on what business outcomes are, obviously buying versus building is usually better. Nowadays, though, building can give you a competitive edge if there is if you believe that you can build some differentiation. And we're very careful making that decision, the distinction between buying versus build. A decade ago, buying was the prevailing decision for tech teams across multiple industries. Nowadays, it's not as obvious. Building may actually be the way to go. So once you're clear on the business outcome and you are clear on buy versus build, I think progressive companies are thinking cloud first. And if you're thinking cloud first and you're following the principles that I just mentioned, then it's very likely that you will have a multi-cloud environment because you will be buying solutions that are running in different clouds because you are getting the business benefit associated with that solution. So architecting your solutions from the get-go, being conscious about the fact that you will be running in a multi-cloud environment, I think is extremely important. And I just go back to the point that I made, data privacy or data management. You cannot have a lower standard for on-prem capability versus cloud or vice versa, because then that's going to come back and bite you. And finally, the last point about on-prem versus cloud. I mean, you can be cloud first, but the fact is there are some laws of physics that are there. You have in our case, in our industry, we have a lot of IoT devices where latency matters. Therefore, you have to have compute capacity close to, factories, and that's an obvious decision. So the decisions seem to be easier on the extremes, where you're either pursuing value in an area where you don't have the capability, or closer to your premises where latency matters. The difficult part is in the middle, and therein lies the challenge.
Maybe coming back to Elissa's key pillars, cost, and Mike, maybe you can start us off here. FinOps is, as you have hybrid clouds, multi-clouds, and have to move processing all over the place, IoT devices needing and creating a bunch of data. How are you seeing companies sort of align around the governance and the on-demand nature of the public cloud in and around some of the FinOps issues and cost and expense issues?
Yeah, everybody kind of underestimates the problem at first. It's like trading in an old car for something really new, shiny, and the first couple of days you put a lot of miles on it till you realize just how much gas or how much battery you're spending. And then comes some wising up, and there's now an entire industry out there in terms of cost monitoring and cost modeling and so on and so forth. And as far as I can tell, that works fairly well. I think what we see with our customers is, at the beginning, really a period of time to kind of get used to that, to really understand what are the different factors here. Most of our customers come from a hardware footprint, a fixed hardware footprint for their data warehouse. And so for them, that's kind of taken off the table. It's a fixed boundary box in which they operate, and they can do whatever they want. They would never kind of exceed the cost of this because it's fixed. And so for them, the first couple of weeks, months, and quarters is kind of a bit of a getting used to it period. Because one thing that really has, I think, made a huge difference when we talk especially data management in the cloud is you trade off a lot of tinkering with your fixed hardware footprint for flexibility and scale in the cloud. And by that I mean, especially in databases, you might end up tinkering with a bunch of queries, a handful of queries, for months and months and months, and spend tens of thousands, if not hundreds of thousands of dollars to kind of get that query into that database to work on it. Whereas in the cloud, well, you move that slider a little further to the right and that problem goes away. And that is a completely different way of thinking about it. Naturally, it's also a little treacherous because you might move that slider a little too far, so you need to be careful with that. But that is a huge change that our customers or anybody who moves initially to the cloud first needs to wrap their head around, that this might be a little more expensive on OpEx, but you're saving yourself so much on these hidden costs that were so dramatic. And so once they get this, I think there's a huge aha moment there.
And running Nest, Lisa, I'm wondering how you think about as having one of the largest, most important cloud providers, but also maybe being a customer as well, how you think about the cost trade-offs between where and how you want to run different processing capabilities, how you think about cost both from an external perspective as well as internally.
Yeah, it depends on the problem that you're trying to solve, right? Like if you're building an application that could be hosted anywhere, it's much simpler than if you're trying to solve a machine learning problem where it makes sense that you want to tune your model up in a cloud that has the type of compute capabilities that actually allow for that. So it really depends. Often it's how do you get to the business outcome, as Jaime said, that you want as quickly as possible. And that has trade-offs in terms of cost, it has trade-offs in terms of latency, and it has trade-offs in terms of the type of data that you use. Because what they're learning now is that it's not just about the amount of data you have, it's the number of parameters, how you tune them to generate the most accurate result. And so thinking through what is the business outcome that I want, then factoring in the trade-offs in terms of architecture and providers, I think that's a case-by-case basis for any enterprise that's out there.
And how far along, Jaime, do you think the industry is in being able to deliver all those trade-offs, if you will, so that you have, as a consumer of cloud services and a heavy user, are we early stages in truly being able to affect high impact FinOps, or are we sort of still in the mid game?
I think we're in early stages. It's obvious. For us, the way I think about this is for companies that are moving from a primarily on-prem environment to the cloud. The first challenge is to move from a capital-intensive model to an expense-intensive model. So making that transition is going to be painful. It's going to take a while for you to understand the dynamics. You used to buy extra capacity and subutilize it, sweat the asset for a long time, and you had a lot of choices. A lot of flexibility. Obviously, there was always a hidden cost of speed to market or service to your customers that it was hard for you to understand. As you move to the cloud, it's different. As Mike just mentioned, it's as simple as, do I need more computing power to shorten my life cycle or my time to market for this specific feature or capability? And you can make it happen. And now figuring out the cost benefit is going to become increasingly critical, because you will have a lot more choices to make in a never more complex tech landscape in your company. So I think FinOps needs to continue evolving into being more of a data-driven model Tools will have to evolve to be able to inform decision making, to be able to enable operators within companies that are using cloud services to be able to experiment and test about different models. But definitely FinOps will need to continue evolving into being more of a data-driven model that enables improved decision making that is more ROI based.
More data, more cloud, I guess.
More data, more cloud.
Maybe one of the elephants in the room around cloud is power and power consumption. We talked a little bit in the last panel about the semiconductor industry as a force for good. How in your various organizations, things like power or maybe we can't talk about ethical AI for everybody, but things like power and other areas around climate change or impact or communities, et cetera, are those things increasing importance? Obviously power is, but all of the other ones from an organizational top-down perspective, how much focus is there on sort of the non-just cost, just delivery, but the greater good, if you will? Lisa, why don't we start with you?
Yeah, sure.
Feel free to ignore the ethical AI one that we want to talk about right now.
So, I mean, power's, somebody on the last panel commented that power is one of the greatest considerations because you have to have enough power to generate, to power all of the computational needs of a data center, as an example. So power is at top of mind for everyone. And then really there's a ton of innovation that's happening, not even in the data center. And you can look to Google to see lots of innovation in terms of power management. But then also, I think somebody in the last panel mentioned smart manufacturing and how power management's done, particularly as commodities are becoming, and utilities are becoming more scarce for data centers and for any type of manufacturing firm. So having a core competency from a business perspective that takes into account and innovates in power, whether it's how you utilize that power coming from the power source or how you utilize it within the data center or in the smart manufacturing capability, is going to be one of the things that really sets companies apart moving forward. So I don't think it's just limited to a cloud provider, as an example. I think it's very important for anyone who's doing manufacturing at scale to consider how they actually power whatever they're trying to do, whether it's a foundry, as an example, and how they take power from the grid and how they optimize that to have a competitive advantage over others in their industry.
Yeah, I think ERG is increasingly important, and practically in every industry there are different industry efforts tackling that, and we're happy to see hyperscalers being concerned about power. In the case of manufacturing industries, I mean, obviously power, the compute power is a small component of the power that we consume. More importantly, the carbon footprint that we create. So if you just think about, the cheapest inventory is the one that was never created, or just think about how cheaper it is to move data versus inventories, and the impact that can have in carbon footprint or energy consumption, better human being. And so I think the trick here is automation. How do we leverage the power of the cloud, the power of AI, the power of granular data to improve the degrees of automation of your business. And the more automated it is, the less carbon footprint you will have, the more just-in-time service of consumer or customer needs you'll be able to provide, the better well-being for employees working in your company because they have hopefully higher quality of life.
Great. I think we're just about out of time, unless you want to do one more. Nope, out of time? Okay. Sorry. Awesome. Well, thank you so much. It's been a great honor to be on the panel with you all, and I certainly learned a lot.
Thank you so much.
Thanks.